Right, so today we're going to look at geometric sequences in series. So a geometric sequence is a sequence where we multiply by the same number to get the next number each time. So each number in the sequence is multiplied by the same number. Now, even if things are being cut in half, we're still using multiplication. We're not going to do division. Okay? Because what happens is a geometric sequence is actually, what do we call these graphs that look like this? Exponential. Okay? So if you remember with exponential, everything we do with them is always multiplication also. Just if b, when we're doing exponential functions, if b was greater than 1, we had growth. And if it was between 0 and 1, we had decay. And the same thing happens with geometric sequences. The common ratio is the thing that we're multiplying by each time. And if the common ratio r, if that's greater than 1, then the numbers get bigger each time. And if it's less than 1, then the numbers get smaller each time. Okay. So similar to arithmetic, where we add or subtract to move on to get the next term, with geometric we are going to multiply to get the next term. So we have what's called a common ratio. All right, so we're going to start out just by identifying whether sequences are arithmetic, geometric, or neither. So we're looking for a common ratio, common difference, and if we don't have either of them, then we stop. So the first thing I'm always going to look for is a common difference, all right? So here we have 100, 93, 86, 79. All right, so I subtract a couple of these numbers. 79 minus 86 is negative 7. 86 minus 93, negative 7. 93 minus 100, negative 7. Right? So the sequence here, they all change by negative 7, so this is an arithmetic sequence. We found a common difference of d is equal to negative 7. But we'll always, first thing I'm always going to do is look for an arithmetic sequence first. Is it arithmetic? All right? So we look for, here we got 180, 90, 60, and 15. So is there the same amount between each of these when we subtract? The distance from 180 to 90, is that the same as 90 to 60? No. Okay, so it's not arithmetic. All right? So we'll try geometric. And with geometric, because we're looking for a common ratio, that means we're going to be dividing. So we're going to do 15 divided by 60. Is that equal to 60 divided by 90? Is that equal to 90 divided by 180? Okay, are those equal? Are those equal? Well, this is a half, this is 2/3, and this is a quarter. So these are not equal. They don't have a common difference, so this would be neither. Bless you. Okay. All right. And one more. Bet you can't guess what this one's going to be. All right, 5, 1, 0.2, and 0.04. Is the distance from 5 to 1 the same as it is from 1 to 0.2? No, okay, because we have a difference of 4 and a difference of 0.8. So it can be arithmetic. So let's check geometric. All right, 0.04 over 0.2. Is that equal to 0.2 over 1? Is that equal to 1 over 5? So I'm going to check those ratios to see if they're the same. And since it is a sequence, we really only need to check two of them. Okay? If two of them are the same, then we're going to figure that the third one is going to be the same also. So this case, these are all the same. They're all either 0.2 or 1/5, whichever way you want to write it. And so this is a geometric sequence. And it has a common ratio, r, that's equal to 0.2 or 1/5. So arithmetic has a common difference, and we use d to represent that. Geometric has a common ratio, and we use r to represent the common ratio. Now, there's two ways to look at geometric sequences. One is using the recursion formula or recursive formula. We talked about this the other day. That with a recursive formula, that just means that we're going to take the last answer we got, and in this case, because it's a common ratio, multiply it by the common ratio. Okay? So the last answer times the common ratio, which is what this says here up at the top. Okay? But the big thing we want to look at is the general rule for a geometric sequence, which is, I'll write it bigger, a sub n equals a sub 1 times r to the n minus 1 power. A sub n equals a sub 1 times r to the n minus 1 power. Where a sub 1 is our first term, and r is the common ratio. Okay? And that's that number we talked about with b when we were doing exponential functions, because this looks just like an exponential function. So if r is larger than 1, the numbers are going to get bigger and bigger and bigger. And if r is less than 1, the numbers are going to get smaller and smaller. All right, so this is define the nth term of a geometric sequence. So you now have two general rules, one for each. All right. Okay, so let's find the seventh term of this sequence. 3, 12, 48, 192. Now, one of the things I want to remind you is that sometimes just taking your calculator and keep multiplying will get you there faster than actually using the formula. Okay? Like in this case, if all they want is the seventh term, they've already given me 4, I only need to do it 3 more times. Okay? So first of all, what's the common ratio here? Okay. All right, so r is 4. 12 divided by 3, 48 divided by 12, 198 divided by 48. So you could then just do 192 times 4, and times 4 again, and you'd get your answer. Okay? Or if we want to use the formula, so a sub 7 would be equal to 3 times 4 to the 7 minus 1 power. Okay. A sub 1 times the common ratio raised to the n minus 1 power. So either way you do it, and it's up to you, I don't care. All right? We get what, Jordan? 288? Okay. All right, for finding the nth term of a geometric sequence. All right. Okay, to find the nth term given two terms. Right? So find the 8th term of the geometric sequence with a sub 3 equal to 36 and a sub 5 equal to 324. So this is similar to when we were working with the arithmetic ones the other day. So here's our general formula, but I'm going to change this like we did the other day. So this would be a sub n, and I'm going to make this a sub m. Okay? So we have the nth term and the mth term, times r, and this is n minus m here. N minus m. So we're going to set it up like this. And first of all, to find r. Okay? To find r. So we have 324. So in this case, we're going to say a sub 5 equals a sub 3 times r to the power of 5 minus 3. Okay? And it's always got to be the bigger number on the left, smaller one on the right, as far as the term numbers are concerned. Okay? So 324 equals 36r squared. So what do I do to find r then? What's the next step? Divide by 36. All right. So r squared equals 324 divided by 36 is 9, right? Okay. Now, to find r, we have to do the square root. Okay, we all know that. The thing to remember is that since I'm solving an equation and taking the square root, we're going to get what, Jasmine? Plus or minus. So r equals plus or minus 3. So potentially, there are two answers to this problem, not one. Okay. In some of the problems you do, there are going to be two answers and not one. No, they both work. Okay. The thing is that, and we'll look at it real quick here then. Okay. So we want to find the eighth term. Okay. Well, and I'm going to expand this. I don't need that. Okay. All right, so we found r, and we want to find the eighth term, and we know the fifth term, right? So let's do it manually. All right? So take out your calculator, right? And we're at 324, okay? And that's the fifth term, right? So if I multiply by 3, what do I get? 972. So that's the sixth term, correct? So here's the fifth term, here's the sixth term. Seventh term would be what? 2916. Okay, 2,916. And then the eighth term would be what then? 8748. Okay, 8,748. All right, positive number. Okay, now this is using 3. What if we use negative 3? All right, so the fifth term is still 324, but the sixth term would be negative 972 because we're multiplying by negative 3. The seventh term is 2,916 still, but the eighth term is going to be negative 8,748. So there are two answers to this problem. Positive 8,748, negative 8,748. And so you have to report both terms. And they both work. Because we don't know what's between 3 and 5. Okay? So all this tells me is that the odd terms are going to be positive, like 5 and 7, but then the even terms end up positive or negative. So you have to take both of them into account because we don't know for sure. Right? Two answers for the eighth term. Okay. So I could do it this way. If I wanted to use a formula, I could say a sub 8 equals a sub 5 times r to the 8 minus 5 power. So a sub 8 equals 324 times 3 cubed, but I would also have to do 324 times negative 3 to the third power. Okay. You have to do it with both of them, because I don't know which one it is. So I have to have both. So either way, take 324, multiply by 3 times, or multiply by 3 to the third power, or negative 3 to the third power. Okay. Similar to when we found D in the arithmetic ones that were like this, when we find R, just go one way or the other how many times from the last term you used to the one you're trying to find, or do it backwards if you're going to go to previous ones. So if we knew the 7th term and we wanted to get to the 5th term, then we would divide by that certain amount twice to get there. Okay. All right, geometric mean, we kind of hit on this real quick yesterday, but all a geometric mean is we're just going to take the square root of the product. So geometric means are the terms between any two non-consecutive terms of a geometric sequence. If A and B are positive terms of a geometric sequence with exactly one term between them, the geometric mean is given by the following expression. So this is probably the easiest thing we could do. Right. Square root 4/9 times 25 over 36. Okay. And when they give us easy numbers like this, we could actually simplify them and then do the square root, or however you want to do it. Square root of 100 over 324, which is 10 over 18, or 5/9. And actually, if you remember when we worked with square roots before, radicals before, I actually could do square root of 4/9 times the square root of 25 over 36. I could do that also, and it would still give me the same result. 2/3 times 5/6. So, geometric mean. So what's the geometric mean with 16 and 25? Right. Well, square root of 16 is 4. Square root of 25 is 5. 4 times 5 is 20. Thank you very much. Just let me learn about that. Okay. All right. Finding the sum of a geometric series. Okay. So now we're adding them up. Right? You added them up before when we were doing those ones previously. Well, here's the formula then right here for finding the sum. All right. So just like any one that we did with arithmetic, I said, you could just expand the series, write them all out, add them up. Okay? And if you would prefer to do that, you're more than welcome to. If you want to use a formula, you're more than welcome to. Whichever one is the most convenient for you to do it. The only thing is, when you have the formula, if it's a very large group of numbers that you're trying to add, much easier to use the formula than just to plug them in your calculator. All right, so we need a sub 1, our first term, r, the common ratio, and n to be able to find the sum using the formula. So in this case, a sub 1 is 1. And what's happening from one number to the next? Okay, we're doubling. So r is 2. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. Okay? And they tell us they want us to find the sum of the first 8 terms, so n is 8. So s sub 8 equals 1 times 1 minus 2 to the 8th power over 1 minus 2. And this is okay because the numerator is going to be negative and the denominator is going to be negative, and the negative divided by negative is positive. So all you got to do is plug that in your calculator and it will give you the correct answer. $255. Now, when we have summation notation with the geometric one, a sub 1 is when, just like it was with arithmetic, I put 1 in for k, and what do I get? So this is the absolute value of 1/2 to the 1 minus 1 power. Right? Well, what's 1 minus 1? 0. Okay, and anything raised to the power of 0 is 1. So a sub 1 in this case is 1. Now the common ratio is always going to be the number that's being raised to a power. Okay? So in this case, the number being raised to the power is 1/2. Now if it said something like this, sum k goes from 1 to 8 of 2 times 3 to the k minus 1. If it looked like that, okay, then the value of r would be 3, okay, because 3 is being raised to the power. Okay, the 2 is outside the parentheses, that's not being raised to the power. So in that case there, the common ratio would just be 3. Okay. And we're trying to find the sum of the first 6 terms. So s sub 6 equals 1 times 1 minus 1/2 to the 6th power divided by 1 minus 1/2. Can you do it? Oh. All right. What did we get? 1 over 32. You guys agree with that? I'm having a hard time with that considering the first term is 1, and if we're adding them up, it better be bigger than that, right? Okay. It's a little bit tougher to put this in your calculator, so. What could I do then to make it easier to put it in my calculator? You could break it down. Okay, that's one way. What else could I do? Put 0.5. Okay, change the fraction to a decimal. And it's much easier to put 0.5 in and raise 0.5 to a power than it is 1/2. Alpha So we put a fraction, 1 minus 0.5 to the 6th power over 1 minus 0.5. And if I change that to a fraction, which is what I would rather you did, you'd get 63 over 32. Yep, since we're using a fraction here in my problem, I should have a fraction in my answer then. Okay, application problem. All right, these you were working with before. Here we got an online video game tournament begins with 1,024 players. 4 players play in each game, and in each game, only the winner advances to the next round. How many games must be played to determine the winner? And I'm going to cover this up because I don't even want to use it. All right. So let's do this. Let's start out and write it as a sequence to begin with. So we have 2 key numbers here. 2 key numbers are 1,024, all right? And the other key number we have is, what? What's the other key number? There are 4 players, okay, in each game. Okay? So we have 1,024 players total, and 4 players per game. So, for those 1,024 players to play, how many games must there be? How many? 256. Okay? So in the first round, round 1, there are 256 games. Right? Which means there's 256 winners, right? Okay? All right. So then how many games are there for round 2? 64. How'd you get that? Divide it by 4. All right, does that make sense? So then round 3, there are how many games? 16. Round 4, how many games? 4. Right. Is there a round 5 then? Okay, round 5, there is 1 game. Okay. 1 game. Okay. So the question is, how many games must be played to determine the winner? Well, right, we add them up. Now, that's the answer I expected from people too, Sarah, is because people forget that it's not the rounds that I'm concerned with. It took 5 rounds to get the winner, but how many actual games did it take? And so I've got to take and add these numbers together. bless you, which is how many games?
341.
341 games to get the winner. So in problems like this, some of these story problems, like this one especially, I don't rely on the formula to do this. Okay? I rely on setting it up, making a list of what the numbers I'm going to need, and then just adding them together. Usually easier.